symmetric interval where 0 is the center. So now you have 1 minus absolute value of x. You get a symmetric interval. Now we'll look, is the thing even or is it odd or is it neither? You're hoping it's either even or odd. So is 1 an even function? It is. Any constant is even. No, every constant is even. Every constant is even. What about absolute value function? Even or odd? Even.
Oh yeah, because the V.
It's a V shape, right? It's symmetric about the y-axis. There's your absolute value function. So it's even. What's an even minus an even? Even. When you add and subtract evens, you get an even. So this is an even function. So this should be the same as computing the definite integral from 0 to 1, but doubled, right? When it's even, you double it. 1 minus, I'm going to write absolute value of x. We're going to change it 1 second. So what does this do? Now that I'm from 0 to 1, what can you do with the absolute value of x? Right, it's x. Right? Absolute value of x is x whenever you're dealing with 0 to 1. So that's why you do not have to actually anti-differentiate the absolute value of x at all. Right? Once you confine yourself to the zeros and positive values, then absolute value of x is just x. So what's the antiderivative of 1? X. So now you have 2 times x minus x squared on 2, evaluated from 0 to 1. Polynomials, so at 0 it's 0, so you need to compute is the upper limit. So 2 times 1 minus 1 squared on 2. 1 minus a half is a half, half times 2 is 1. So you get x squared. Where do I get this? Antiderivative of that. That's what you're trying to do. You're trying to alleviate the absolute value by putting yourself on only a positive interval. 0 doesn't count because, again, the inputs don't really matter. So it's really a positive interval.
You got. So we'll find interval between 1 and -1, right?
That's the interval we're on.
Okay, so oh yeah, because 2 times that 2 is accounting for the area on the other side. Is that correct?
That's correct. You're doubling the same area. It's the same as 1 minus sine x we had previously. Very similar. Only there it all canceled out. 1 minus absolute value of x is simply this. There's your picture. There's 1 minus absolute value of x. And so you're trying to find, there's -1, and there's 1. You're finding this area. So computing over the whole thing, -1 to 1, is essentially the same as taking just 0 to 1 and doubling it, because they're the same. That's all you're doing. 13. The integral from something to something of sine 5th power of x dx. I hope it's symmetric. No, otherwise we're stuck. Negative pi on 4 to pi on 4. All right. So symmetric interval, it is. Negative pi on 4 to pi on 4 symmetric. Now sine to the 5th power. Sine to the 5th power.
Chain rule.
No, don't do chain rule. Forget that. I'm trying to do antiderivatives. But you're not going to find antiderivative sine. You don't know how to do that. So do you have to do that? The point is no. If you have a symmetric interval, you shouldn't have to. So all you have to do is ask yourself, is this an even or an odd function? Or neither? Odd. It's an odd function. Put inside an odd function, right? 5th power is odd and sine is odd. So it's going to be odd. So that means the answer is 0. Right? The area on the left will cancel the area on the right completely. Number 11. X over the root of 200 minus x squared. X from -10 to 10. So we'll figure out how to take these antiderivatives in the next section, which will be what you call U substitution, which is trying to undo a chain rule. U substitution undoes chain rule. That's what we'll do next class. Right now, you're not able to compute this antiderivative. So, yeah?
Since it's an odd function on top of... Oh, that's a mixed function.
No. You're okay. Go ahead. Keep talking. What were you saying?
Well, I thought it was an odd function on top, and then you had a even function on the bottom.
You do.
So it's odd.
And so it's odd.
It is.
So that makes it 0.
It is. And so you did not have to take any antiderivatives, right? You just compute the area directly through properties of symmetry.
I thought...
But in the next section, we're going to compute this antiderivative because you don't always get symmetric intervals. It's going to be -5 to 10, and then you're a creek, right? So you want a method for trying to find the antiderivative of this thing. And that's what we'll do next time.
I thought like the root of 200 minus x squared would be like a mix, because 200 is a even number, right?
Say again, 200 is an even. 200 doesn't matter if it's even or not. It doesn't matter. So you have a constant, which is even. X squared is even. The difference of an even, 2 evens is even. So that's it right there. And like I said, the top is odds. So products or quotients of odds and evens are going to be odds. One more. They got us a very strange looking one here. Number 12. Cos 2x plus cos x sine x minus 3 sine x to the 5th. 3 sine x to the 5th x over the interval -pi on 2 to pi on 2. Oh dear. All right. What do you think? Is it 0? Well,
Because
why?
cosine 2x, x is by itself now, how would you want that on?
Well, hold on a second. Cos itself is even though. Cos is an even function. Right, Lee? Cos is even.
You gonna break it up?
Oh, okay. First of all, tell me what each piece is. Is cos 2x even or odd?
It's a million.
It's what?
Cos 2x is rational, it's a mixed number. So it's not odd or even.
This 2 doesn't affect anything.
So it's even.
It's even. Cos 2x is even. Remember that even means symmetry about the y-axis, right? Symmetry about y. And what does 2 on the inside of this do? It shortens, it shrinks the function about 0, right? It shrinks it. So it's still symmetric though. It shrink equally on both sides, right? So it's still even. So that part's even. Now what about this part? Cos x sine x. Should be, yeah.
So can't like